10th question A part. Consider voltage divider by circuit of JFET. If RD is equal to 1.2 kilo ohm, RS is equal to 2 kilo ohm, R1 is equal to 20 kilo ohm, R2 is equal to 10 kilo ohm, VDD is equal to 12 volt, IDSS is equal to 12 milliampere, VP is equal to minus 4 volt. Calculate ID, VGS, VG, VDS and VS. Draw the circuit diagram. It is asked for 10 marks and it is from August-September 2020. Okay. So what you have to design, given what are the parameters, you have some parameters given. Now you have to consider voltage divider by circuit of JFET. Okay. So we have to calculate, these are the values which we have to calculate, and we have to draw the circuit diagram. So first solution, let us write the given data. So okay, RD is given, RS, R1, R2, VDD, IDSS and VP. And what are the parameters which we have to find out? ID, VGS, VG, 1, 2, 3, 4, 5 parameters we have to find out along with the circuit diagram. Okay, so we know that it is a voltage divider circuit. So this is your circuit of your JFET. So you will be getting what is your voltage divider biasing. Across the input you have your voltage divider, that is R1, R2. Across the output you have your drain resistor. Across the source you have your source resistor. So this is your diagram of your voltage divider biasing. Okay, and the supply will be connected to your RD and R1, and the junction, the R2, the voltage across R2 is taken as your VG, that is your gate voltage. So how you can find out your VG? VG by applying voltage division rule, you can find out your VG. Okay. So now first clue is that you can apply the input loop equation. So this will be your one loop and this is your output loop. Okay. So these are the two loop equations which you are going to apply. Kirchhoff Voltage Law. Okay. So let us begin with applying Kirchhoff Voltage Law across this gate to source. Okay, so here what is your voltage you have? Here it is plus to minus, here it is plus to minus, and here it is plus to minus. Okay, so this will be your one loop. So what will be your Kirchhoff voltage law? So I am taking from negative to plus, right? So what is your voltage here? VG. So take the second polarity, plus VG. So what will you get? KVL across the input. So what you will be getting? So minus to plus. So second polarity, plus VG. Here you have plus to minus. So second polarity, minus VGS. So what will be the voltage across this? The same current. The current ID will be flowing across your output, right? Same current will be flowing across your RS also, ID. So the voltage across this is equal to VS, which is nothing but equal to current into your resistor. So here also it is plus to minus. So second polarity, minus ID into RS is equal to 0. Now from this can we take the value for VGS? Now VGS is equal to, if I take this to the opposite side, VGS will be equal to VG minus IDRS. So this is the equation which you have got here. Okay, the same equation. This is how you are getting the equation, by applying your KVL across your input loop. Okay. Now how will you find out your voltage VG? VG, you know that. So if I take this is if we apply voltage division rule, what will be your supply voltage? Total voltage, that is your VDD, into the resistor across which it has to be calculated. So what is the resistor? R2 divided by the total number of resistors. So I can write here, this is due to your voltage division rule. Okay. You will be getting VG is equal to VDD into R2 divided by R1 plus R2. So you know what is VDD is given. VDD is equal to 12 volt. So 12 volt into 10 raised to 3. What is your R2? R2 is equal to 10 kilo ohm divided by total number of resistors, R1 plus R2. R1 is equal to 20 kilo ohm plus 10 kilo ohm, which is equal to, just do the simplification. So I have done here simplification. 12 into 10, 120K divided by 20 plus 10, it is 30. So when you cancel, you will be getting 0, 0 can be cancelled. Here also it is K, here also it is K. You can cancel both. And here 1 3 is 3, 4 3s are 12. So you will be getting VG is equal to 4 volt. You have got the answer VG. Now once you have got the value for VG, can you substitute in your first in your VGS equation? So VGS is equal to VG minus ID into RS. Instead of VG, substitute the value 4 volt. That is what which is done here. So take this as equation 1. So from this, reconfigure it and find out the value for ID. So minus ID into RS is equal to 4 will go this side. So you will be getting ID is equal to minus VGS plus 4 volt divided by RS. Let me take this as equation 2. So one of the parameter we have found out, VG. Okay. Now we know what is the value for ID also. Now moving on to the next, you will be having, also we know that what is your ID equation. The current ID is given by means of Schottky's current equation, right? So ID SS into 1 minus VGS divided by VP the whole square. So you know that ID you have got here one equation, and previous case also second equation you have got ID is equal to 4 minus VGS divided by RS. Now can we equate equation 2 and 3, because you have both the LHS is equal to same, right? Both the left hand side are same. So if we equate both the right hand side, 4 minus VGS divided by RS is equal to IDSS into 1 minus VGS divided by VP. So just reconfigure this, take this RS towards this side, that is the step which is given here. Now you substitute the values. So what you will be getting, your 4 minus VGS RS is equal to 2K, IDSS is equal to 12 milliamperes. So 12 into 10 raised to minus 3 into A minus, this is in the form A minus B the whole square, right? What will be your value? A square minus 2AB plus B square, right? That is what it is written here. 1 minus 2 into AB, 2 into 1 into B is VGS divided by VP plus B square. B square is VGS square divided by VP square. So that is what written here. Now 12 into 2 cross multiply, 10 raised to 3, 10 raised to minus 3 will get cancelled. So you will be getting 24 into 1 minus 2 VGSP plus VGS square divided by VP square. Similar. Now bring this all towards one side. So what you will be getting, when you bring it to the opposite side, you will be getting 24 into minus 4 plus VGS is equal to 0. So just cross multiply it inside. Okay. So you have expanded 24 plus. So instead of VP, you know VP is equal to minus 4. I have substituted this value and you are cancelling it. And when you cross multiply it inside, you will be getting, this will be your equation. Just reconfigure it by means of quadratic equation. So you will be getting here VGS square, VGS and your constant value, right? So you will be getting 24 by 16 is nothing but equal to, let me check once again. So 24 divided by 16 is equal to 1.5. So 1.5 VGS square plus 13 VGS plus 20 is equal to 0. Now you have got a quadratic equation, right? So it is difficult for you to do it manually. So since this quadratic equation is time consuming to solve, let us solve it using your calculator. Okay. So if we want to solve the quadratic equation, we have to turn into your quadratic mode, right? So press the mode and you will have equation. So under equation you have 1, right? 1. Then press the right side. We have to select which degree. So it is second, right? Degree is 2. Now it will ask for your value of A. Here the coefficient of A is 1.5. So type 1.5, then equal to, then it will ask for B. So the value for B is 13, equal to, the last coefficient C is equal to 20. So enter 20 equal to. Now you will be getting the answer. X1 is equal to minus 2. So VGS will be equal to minus 2 and minus 6.666. So this is your VGS is equal to, second answer is minus 6.666 volt. Okay. So now if you have to bring back your calculator into a normal mode, what will you do? You will just press shift clear. You can reset by pressing all, right? So 3, press 3 equal to, it will be resetting all. Okay. And it will come back to your 0. So this is how the easy method for your exam which you can follow. So you have got VGS is equal to minus 2 volt and VGS is equal to minus 6.66 volt. Now in this, among this, which value will you select? We should select the value which is within your VP. Now VP in your question is equal to minus 4 volt, right? So we will select VGS is equal to minus 2 volt, which is within that range. So VGS is equal to minus 2 volt. Now you have got the value for VGS also. Now you are going to substitute the value for VGS in equation 2. Now what is your equation 2? That is a value for your current ID. ID is equal to minus VGS plus 4 volt by RS, right? So instead of VGS, you are going to substitute minus 2. So your minus 2 into minus 2 plus 4 volt divided by 2 into 10 raised to 3. When you solve this, you will be getting 3 milliampere. So you have got ID also, which is equal to 3 milliampere. Now you have got VGS, ID, and what are the other values you have got? VG. So 3 values you have got, right? Now the next 4 and 5th value, VDS and VS. In order to find out, you are going to apply your Kirchhoff Voltage Law to the output side of the circuit. So when you apply Kirchhoff Voltage Law to the output side of the circuit, what you will be getting? Here also the same way. Your starting point is VDD. So plus VDD, what will be your value? Plus VDD. Here the current flowing is ID. So the polarity is plus to minus. Take the second polarity, minus ID into RD, right? So here it is plus to minus. In the junction you have your voltage VDS. So minus second polarity. So minus VDS. It is ending towards your source, right? The same current is flowing. Here the polarity is again plus to minus. So second polarity, minus ID into RS is equal to 0. So same equation I have written it here. VDD minus ID RD minus VDS minus ID into RS is equal to 0. From this, can you calculate the value for VDS? So VDS, bring it to the opposite side. So you will be getting reconfigured, right? So VDS will be equal to VDD minus ID into, you can take it as common, ID as common. So RD plus RS. Substitute all the value. VDD is equal to 12 volt, ID is equal to 3 milliampere, 1.2K and 2K. When you solve it, you will be getting 2.4 volt. So VDS will be equal to 2.4 volt, and what will be your value for VS? VS will be equal to the current into your resistor. Current flowing is equal to ID. ID into RS, which is equal to 3 milliampere into 2 kilo ohm, which is equal to, both will get cancelled, 3 2s are 6 volt. So what are the parameters which you have found out? Now you have to find out 5 parameters, right? ID, VGS, VG, VDS and VS. So ID, which is equal to, what is the value for ID which you have found out? ID is equal to 3 milliampere. VGS is equal to, what is the value for VGS? VGS is equal to minus 2 volt. VG is equal to 4 volt. VDS is equal to 2.4 volt and VS is equal to 6 volt. So this is how you have to find out all the values.